Hello friends, today we'll see how to do the logic configuration in DIGSI for Siemens relay. This is the logic sheet for the closing logic. Here we see for the incomer breaker, here we see the breaker in service, spring charge, CB spring charge, TCS input, CB open, bus coupler fault, bus coupler on and in service, close from DCS, then relay in local remote, and close from HMI and or laptop. The above are the service close position and below is the test close position. This is the logic diagram for the tripping logic. We have trip from DCS, CB in test, service, CB open. These are the inputs, binary inputs. And here we have a sheet for the binary inputs and the outputs and the LED configuration. This is the 7SJ66 relay with all the CT and the PT inputs. Now we'll open the DIGSI software. I'm using 4.95 version. I've already created a new project, so I will open that project and right click on the page. We'll open the device catalog and we'll select 7SJ662 version 4.31. Here the PSET version is 4.36. So we'll go with PSET version 4.36. Now here we have to write the MLFP of the relay, which I have already written on a notepad. The MLFP you will be getting in the settings of the relay. Here the new file is created. We'll name it as test incomer, as we are doing for the incomer breaker. Now we'll open the file in offline mode. And we will save the file at the first instance. Then we will continue with the configuration and CFC. So first we have to open the settings, then masking IO. In masking IO we have to define all the binary inputs and the binary outputs from the relay diagram as shown previously. In the device configuration, you can enable or disable any protection which is required. Here we are enabling the synchro check as it is an incomer breaker, so synchro check is required, and trip circuit supervision with 2 binary inputs. Now we see that in masking IO, the synchro check function and the trip circuit supervision is enabled, and all the related parameters are being shown. So we'll insert a user defined group after the sync function, and we'll name it as binary input, and we'll define all the binary inputs in this group, and we'll define insert another group called binary outputs, and we'll define all the binary outputs in that group. We'll right click on the binary inputs group and insert a single point indication indication that is on and off for each binary inputs. Similarly, we'll do for the binary outputs. We'll insert the single point on and off indication for binary outputs. Now we'll define or rename the binary outputs by seeing the logic sheet. We have to write the display text and the long text. In 7SJ662, we have 22 binary inputs, and we'll be using only 12 of them. Similarly, we'll rename the binary outputs. We have fault trip, trip command to ACB, close command, trip circuit healthy, bus no volt signal to DDC 86 lockout, dead bus, line healthy, and deadline. Now in the destination tab of CFC, we have to define all the binary inputs that we'll be using in the CFC chart, and in the source tab of CFC, we have to define the binary outputs. Now we are defining all the binary inputs. From 1 to 13, and the binary outputs as it is latched or unlatched. We have to keep saving the configuration. In the control device, we'll insert a double point indication function named as CB or circuit breaker and two single point function for breaker on command and breaker off command. We'll define it in the source tab of CFC and also in the destination tab. Defining all the binary inputs and the outputs in masking IO is the most important and the key part for making the logic configuration in CFC. In sync function, we'll be using sync request function, sync start, and synchronization conditions OK. These three signals will be used in the CFC chart, so we'll define it accordingly. Now we'll open the CFC chart. We see there are two predefined CFC chart, that is device and set points. We can delete these two charts and insert a new CFC chart and we'll rename it as 86 lockout. For making the logic configuration, we need different CFC chart and different run sequence has to be assigned to them, which we'll see as we progress through the logic configuration. Here we see that we have not defined the overcurrent function, overcurrent trip in the CFC destination tab, so we are not getting that signal in CFC chart. So here we are defining the overcurrent function 3 stages and the earth fault function as the destination in CFC, so that we can use it in CFC chart for 86 lockout function. any overcurrent will be operated, the 86 lockout binary output will get high and also fault trip. Now we'll do optimize run sequence, then check consistency and compile. These three steps have to be done after we prepare any CFC chart. Now we'll rename or make one CFC chart, Dead Live Bus. Here we will be taking the line to line voltages or the bus voltage and the PT input voltage, PT voltage, and define the dead bus, dead line and live line functions. So here we have a lower set point and an upper set point block. In the lower set point, if the bus voltages go below a particular value, suppose 27.5, then dead bus condition will happen. Here we see that we have not defined the V sync measurement value. Now we'll set the lower limit of the voltage as 27.5 and the upper limit as 99. Here we will do optimize run sequence and then check consistency and compile. Now insert another CFC chart as breaker command. In breaker command, we'll use a function called connect. If CB off condition will prevail, then start of synchronism bit will be high or synchronization request will start. Now we are converting the single point indication to a double point variable using the build DI block. In the command information block, whenever a command is given to the device or the circuit breaker, then this block will come into picture. Here we see that when we compile, the consistency error is displayed. When you go through the error, it shows that the build DI block cannot be used in MWBRB. So we'll open the run sequence and then we'll put the CFC chart in the proper group and we'll check if the consistency error is coming or not. Here we see that again the consistency error is coming. So we'll put the CFC chart in the interlocking group and now it has not come. Now we'll insert another CFC chart for closing logic and now we'll make the service close and the test close logic according to the diagram. Here we see that again we are getting the consistency error. So we'll put the closing logic in fast PLC. And we see that it is properly executed. Now we'll make the CFC for the dripping logic. So this is the closing logic, and again the consistency error is coming. So we have to put the closing logic CFC in fast PLC and again check the consistency, and now it is okay. We have to save the file and then do the logic LED configuration. We have to assign the LEDs as latched and not latched or unlatched. So for 86 and the overcurrent function, will assign the LEDs as latched, and for other functions such as trip circuit healthy, will assign it as unlatched. Now we'll open the device configuration and we can change the overcurrent function from definite time to IEC, and in the power system data also we can do the required changes as CT ratio, PT ratio. We have put the CT ratio as 3000 by 1, and PT ratio as 415 by 110 volts. So thank you for watching the video. Do subscribe to my channel for more such videos in future. Thank you so much.